Hi there, my name is Yuri Trices, and today I'm doing a tutorial about getting data into R. I'm using Emacs Speak Statistics to interact with the R console, and you can see my Emacs Speak Statistics set up in front of you. I'll explain it a little bit shortly. Basically, what we're going to do in this tutorial is we'll download some data, and we'll read some data into R, and then we'll kind of clean up the data, and then we'll do something with it. So what you can see in front of you, as you can see on the right hand side, we have the script for getting the data, and it's called get_data.r. And on the left hand side, we have the R console, and I've sent over to the R console the instructions get working directory, and that shows us the working directory that we're in. If you want to set the working directory, you can set the working directory using these instructions here. So setting the working directory, and this would be the working directory. When you set the working directory, you want to make sure you have a directory and you don't have a file at the end of the extension. So you can then send this over to the console, and that will set the working directory. When I'm working with R, one of the things I like to do first are set some options. I set these options in my iProfile.site, and the rprofile.site is in your R installation directory, and you can set these options. You can just write these into the script in the rprofile.site, and it will load them automatically for you. Here, what I'm going to do is set the online repository. This is where R will go to install packages, because to do this tutorial, we'll typically want to set up some packages and install those packages. So here we have the options. Options has an argument called repos, and repos is a list of options that you want to concatenate a particular directory that you want to use an online repository to. So here we've got options and repos, and you can see I'm using this repo from SFU, and actually I didn't go to SFU, but this repo is where I like to download my packages from. There are some repos, if you just go ahead and use install.packages and you don't specify the repo, it will go to some default repos, and you can select. You'll have to ensure your firewall will let you go there, and there you can find some repos that have secure protocol if that's something that you're looking for. So my options are already set, but this is how you would go ahead and set options, and you can just send that over to the console. Another option I like to set is the width. I like to set the width at 950. You can see when you set the width, if you have your screen is partitioned, like my screen is partitioned into, I have it with 60% and 30%. So when I'm in an active window, it shows 60%. If you're looking at a data frame and you have several columns and you want to see more of those columns, then you can set this option so you can see more of those columns. So the first thing you want to do when doing any operations with R is you want to make sure that you load your libraries. And to do those, you want to first install the libraries. I'll just show you quickly how to install the libraries you want to use. Here we'll be using install.packages. Install.packages has two arguments. The first argument is packages. There are two arguments that we're interested in for this session, and the second argument is the packages, and the second argument is the destination you want the packages to go into, and that is, I believe it's test file, but we should be able to see here, it'll show us it's lib. So we have packages, and then we have lib. Lib is the library that you want to, this will give you the address or the directory where you want to install your packages into. So first, when we're installing packages into R, you want to have a list of packages that you want to install. Here we just call that list P, and for this tutorial, you'll want deploy R, you'll want Tibble, you'll want Lubridate, and also tidy R. So you can just store that list in this variable P, and then you can set your packages to that variable. Libpath is an argument that you can use, .libpaths. If you send this to the console without any arguments, it will give you the paths that are on your libpath. And you can see on my libpath there are 2 directories within Emacs, and then there's a directory that's within the R installation. So if you're using a computer that has more than one directory, or you want to use more than one directory, you can specify that by putting the path here, or setting a variable with the path here. What I typically do is just set libpaths as the argument here, and then just go ahead and install the packages. So it's not necessary for me to do that here, but you guys can just go ahead and install those packages, and then you'll have those packages. So the next step is to load the libraries, and that's done with the function called library. So here you can see we'll load deploy R, and we'll load tidy R, and we'll leave Tibble and Lubridate unloaded, so I can show you how to call them instantly. There's another way to reference functions inside of the package without loading the libraries, but it's typically convenient to load the libraries if you have that much memory. So the next thing you want to do is get your data, and to get data we're going to use a function called download file, and that's R's, the function that R uses to go online and find the files that you want to get. So what I've done, you can see over here, is I've browsed an online repository, and that repository is at libstat, lib.stat.cmu.edu has some data sets, and what I've done is browse those data sets and downloaded or found rather a data set that is not archived, so it's easier to download it and use it. And that data set is called wind, and incidentally it comes with a metadata description file. So here we've got the description file, and here we've got the data, the file, and these are the URLs that we're interested in. So what we'll do is we'll take these URLs to get the data, and we'll set them into variables, and we do that, we put them in quotation marks, and this allows us to record the URLs themselves. When we save our namespace, we'll have these directions. So we can send these over to the console and load those variables. Download.file comes with an URL argument, among others, and it also has an argument called dest file. So dest file tells you where you want to put the file, and it gives you the name of the file and the extension of the file. So here I've done win.desk.txt. This is a text file. It's the description file that we're going to look at, and we're just going to go ahead and download that. Okay, so that's downloaded. What we can now do, well, I think that's downloaded. What we can now do is download URL2, and we would change this one to data.txt, and we can send that over to the console. And now we can have a look and see if we downloaded these files. There are two functions that we look at here. So this list files shows you the files in the working directory. You can see we have getData.R, and we have wind.data.txt and winddescription.txt. So those are our files. There's another nifty function you can use called just ls, and that shows you everything that's stored in your namespace in terms of variables in the namespace that is your working directory. So that's something that's quite useful. You can also, of course, use your text editor and just go into the directory itself and look at it, or you could, we're doing that right here, or you could, for example, go into your shell and use dir as you would do typically. So here we're having a look at those files. We see that these files are here, and what we want to do now is we want to look at those files and see what it is we've got. So the first thing we'll do is we'll look at win.desk.txt, and this is the description file. We're opening this file in another window, frame, excuse me. We can see here that we have some wind data, daily average speeds from 1961 to 1978 of 12 synoptic meteorological stations. And we can see also that each line corresponds to 1 day of data in the following format, and that these formats are given in order. And so this is year, month, day, and then average wind speed, which is split across 12 stations. And we can also see that the data are in knots and not in meters per second, and that we have 5,300. We have 532,494 bytes of data. So that is the metadata, and now we'll take a look at the data. You can do this in cases where the data file is not that large. This data file is not that large, so we can just have a look at it. And for example, if it's a really large JSON file, then you might not have the memory. You might not want to use the memory, so you might want to just directly parse it into a file and limit the number of records that you're going to parse. So here we can see that we've got these space delimited data, and we've got our year and month and day and 12 stations, and they're two significant figures. So this is a lot of data. It has no headers. We've been given the headers in this other file. That means we can just go ahead and transfer those headers right over, which we'll do right here, and that's a little more convenient. These ones are given in order, we're told, so we're able to do that. We just go ahead and replace this comma with a space, and we should have a data set. and that should work. So we've had a look, and what we did was we looked at the data. We saw that it had no headers. We read the description file, and we were able to take those headers and easily put them into our data file. So now we've had a look. We want to load this data into R. And to load the data into R, we will be using a function called read table. The read table also has a few arguments that we're interested in. The first argument is file. We'll just go ahead and use that file right here. That file in this case would be the one that we've named and that we've adjusted. We want to make sure that we save that file after we adjusted it. And then we would have something called headers, and we would set that to true because we just put some headers in there. We want to set the separator, and we'll set that to the default. You'll note you can't really see it here. We can move up a little bit, and then you'll be able to see it. You can see that the separator, there's a difference between this default, which has no space, and if we put one space in there, that one space, it looks for one space as the separator. The default for read.table is a space or more as the separator, and of course, if you have a type of data that's delimited with a comma, you can put a comma, or if it's delimited with a tab, you can put a tab. So you have the delimiter options. And next, we want to do strings as factors, and you want to set that to false. And we'll read this data into a variable. And it says that there is so it says that we have an error in reading the table. The headers equals true. We have an unused argument. So the unused argument means that this is not an argument, which means it's misspelled. So we'll try it again and see how that worked. And then we can have a look at it. Okay, so we can see that it's worked. So once you've loaded the data in, typically the next thing you want to do is have a look at the data. And there are a number of ways that you can do that. One of them, you can use the head and the tail functions. These are very useful. I use these a lot. There's also a function called structure, which we'll show you. And then there are some other smaller functions that you can use to look at data. If you want, you can use the class. You could use the class. Well, we'll get that. Structure actually gives you the class. You can use dimensions. You can use a number of rows, and you can use number of columns as well. There are a lot of functions that give you information about the data. And here are a few of them. And you can see, typically you will want to use these at some point when you're doing something with R. So it's useful just to see them. So here you have them when you're doing the summary. You probably want to do a summary just for one of the rows, one of the columns, pardon me. And when you're looking for class, you'll see actually structure, which you can see right now. Structure, it gives you each column horizontally, so you can see the columns horizontally. It also shows you the class of the object, the R object that you're using, which in this case is a data frame, and then it shows you the number of observations, 6,574, a number of variables, and it gives you some information in this second column here about the class of the data itself. Here we have integer, 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 and then we have numeric data. So the difference is integers are actually quite a small format, numeric are a larger format, and R will use the numeric format for doing calculations. So if it has really large numbers, it can convert those numbers if the numbers are given in numeric into, let's say, scientific notation, and then convert them back to numeric. So it's a memory saving way that R can um, work with numbers, but it doesn't necessarily save memory in the size of the stored variable. It will save numbers when it's doing actual operations on those variables. But this great thing about structure, you can see it's different than the head and tail, which show you the number of rows that you specify, or the default for the head or the tail, and it shows you those horizontally. You can see, for example, if you go to this row, right now we're down here on row 70, and it wraps over to the next row. So if you go down, we're still on row 70, but now if you go down, you're on row 71. So that's the fact that it's wrapped. Had we changed options, like we set options at 950, if we had set options just a little bit wider, we would be able to see that. Or if we had the screen, rather than being split vertically like it is, if we had it split horizontally, we would be able to see these. There's another way that we can look at these, and that's using structure. And we can also, of course, look at the dimensions, and we can see the number of rows, we can see the number of columns, we can see the length of the data, and then we can also see the summary. The summary will give us some useful information about that particular row, so we can see the range of the data is from the minimum, from 0 to the maximum, which is 25.880, and we can see the first quartile, the median. So 50% of these observations are less than 8.17 knots average wind speed for that station, and then we can see the mean and the third quarter. So that gives us some of that information. So we'll just not worry about class. Class is something that you can get right from the structure. If you wanted to look more closely at class, you could use Saply. We'll do that in another time. So here we've had a look at the data. So what did we see? We saw that we've got a year, a month, and a day, and that we have wind speed in 12 columns. So there is some theory that we like to use for tidy data that specifies we want to have the data in as few columns as are necessary, typically. So in the case of an individual variable, we would want to have that variable in one column, and here we have that variable in 12 columns, so that's something that we'll look at. We can also see that we have years are in 2 digits, and we would typically want to see years in 4 digits. Well, I like to see years as a 4-digit, and we also like to see years as a date format rather than in the integer format. And for the case of this data frame, we want to work with the year and the month and the day, and we want to combine them. That's something that you would typically do if you're when you're working with dates, if you're working with time series or something like that. It gives you the option of more easily working with those dates. So that's what we want to do next, is we want to clean up our data. And the first thing we want to do is we can change that date. We'll change the date to 4 digits. So there's a number of ways that we can do this. One way that we could do this is we could use the mutate, but I'm going to show you that we can do it using Saply. And we would want to look at the year. We want to make sure the year is not capitalized. You can see it actually isn't, so we're good there. And now what we do is we have a look at the year. So what Saply does is it's like there's Saply and Tapley and Maply and Vaply, and these are functions that allow us to basically do a loop. So we'll loop through the data frame or those portions of the data frame that we specify in the first argument, and then the second argument for Sapley will take a function and run that function on the elements that come out of the loop, and so those will be the individual values that Sapley is looping through. So Sapley has the specification of it's a little bit more selective. It chooses the output, so you give it an input and it chooses kind of an appropriate output, and so each one of these functions has a slight difference that you can look at the difference. I tend to use Sapley. There are some times that you'll have to use Apply, or if you're writing a script, you might want to use I think it's Tapley or Apply, but you can have a look at those. And the second argument is a function, and what we're going to do is we're going to write an anonymous function, and our anonymous function will take an input x, and what we'll do is we will add 1900 to that input, and we can just go ahead and do that. So there was a slight error. I think that has to do with what I've done here. So it's probably this. That's correct. We have to spell function properly. Okay, so now we can have a look at wind, and we'll just use structure for wind. We can take a look and we can see we have everything looks the same so far, but now we have this year and it's in numeric and it's 4 digits. So we got the 4 digits that we wanted, but we don't have the year, the month, and the day combined into a date. So that's the next step. We're going to, this is still under the heading of cleanup our data. We're going to, we will combine year, month, day into a date column. So for this, we're going to use the function mutate, and from dplyr. So we will change the name of the variable, which is something I like to do, and then what we'll do is we'll use mutate here, and this takes the argument wind, which is the data argument. The second argument of mutate can be the name of a new file, the name of a new column that you want to bind onto the data frame, and in this case we're going to bind a column, we're going to call it date, and now we want to do two things. One of them, we want to convert this into a year, month, day format, and for this I'm using a package called Lubridate, which I didn't load Lubridate when we started this tutorial. And so what we're doing here with the double colon operator is this is how you call functions from within a package that is installed, but you haven't loaded the library into the namespace. So why would you want to do that? You might want to do that, for example, you had a limited amount of memory, or you had a lot of packages in your namespace, and you knew that you just wanted to call the package just one time. So it's a simple and easy way that you can do that. So the function we want to call is called year, month, day, and year, month, day is looking for input, and that input is something, it's going to search through and find something that's in the format of a year and a month and a day. When it recognizes that, it's going to turn it into an official date format with a string that's year, month, day. So we're going to give it an argument in there. We're going to use with, which is a way of using of doing something with some data within another function. We're doing within the function of year, month, day. The first argument for year, month, day is a data argument. And so we're going to do something with wind as the data argument. And wind is, with takes the first argument, which is wind. There are other ways to do this. For example, with the piping operator, we're not going to worry about that right now. We'll show you something about the piping operator soon. But what we will do here is we will actually use paste. And what we can do is we can paste the year and the month and the day, and we can use a separator for our paste argument, and we'll call that separator so that's just something that has to do with Emacs, and we'll call that separator hyphen, and we can see we have paste year month day. I think we could do it like this. Okay, so let's try that. And then what we can do is we can, again, use structure. This time we can use win2 as the input. We can see we have year, month, day. We have each of our 12 columns, each of the 12 locations that we're collecting wind speed data across the number of years we're collecting the data. And then we have this new column, which we added using the mutate function from dplyr. We named it date, and we used this lubridate package to to combine the year, month, and day values with a separator, and then turn that into a year, month, and day date format, and that works successfully. So there we have the year and the month and the day. So that's great. The next thing we can do is we can get rid of the columns that we don't need anymore. It turns out that we don't need year, month, and day, so we can just go ahead and drop those. And to drop those columns, we're going to use the dplyr package again, and this time we'll use the select function. Select has a number of different formats. When you use select with this underscore, that's something that you'll do for when you're doing scripting, and it takes a slightly different syntax. We're going to use select without the underscore, which is when you're working with the console. So here we have select, and we've got our input. Our input is win2, and we're going to drop some columns. I think this is what we want is a dots argument. So what select does is each of the columns that we name, it will take those columns and it will give us a new data frame with those columns that we named. What you can also do is you can give it a negative operator and refer to columns that it will drop, and we're going to do that. And so we'll use this one of, and we're going to drop these columns that are in here, and those are going to be year, month, and day. So these are in quotation marks, and the reason they're in quotation marks is because one of is kind of like a it's like searching. So it's kind of like grep. It will sort of search through for these strings, and that's why we're specifying that they are in fact strings. And so it's going to drop them, and we're just going to go ahead and see how that works. Now we can have a look at the data frame, and we'll just go ahead and see if it has the columns that we dropped in it. It doesn't. It's got just this one date column, and now it's got these 12 stations. Okay, so we're doing pretty good. We've so far loaded our data into R, and we've proceeded in terms of cleaning it up. We've converted our year column. First, we converted it from 2 digits into 4 digits, and then we went ahead and we converted the 3 separate year columns into 3 separate date columns into a single date column and gave that date column the date format. And now there's only one other thing we wanted to do with our data frame, and that's we wanted to take care of this issue that we have here where we've got our wind speed variable and it's in 12 columns. So when you have one variable that's in 12 columns, one of the things that you can do is you can use the headers of that columns as groups, and then you can use the values that are associated with each record as values. So we use a key value format. So what we would then do is we would want to take each one of these columns and we would want to create 2 new columns, and those columns would have the group, which would be the stations where the data are collected in one column, and in the other column it would have the values, and then it would give us the appropriate date for each one of those records. So that's what we're going to do here. And to do that, we will first let us know that we are tidying the data. Okay, so if you hear the keys are clacking loudly, that's something I haven't taken the time to correct. I like to use this laptop. It doesn't have the best, the keys are kind of loud. They don't have anything underneath them, but you'll just have to bear with me on that. So we're tidying the data. From tidying variable from multiple columns into one. Okay, and to do that, we're going to use the function called gather, which comes from tidyr. So we'll give this a new name, which is typically what I like to do, and then we'll use this gather function. And gather takes as the first argument, it takes the data that we want to input. In this case, we want to input the data frame Win3, and then it takes another argument, and that is the key, and then it takes the value, and then it takes the columns that we want to put into the key. So this key, I think we can do key, and then we can name it, but I think we can just name it, and that's what I'm going to do here. So because this function is arranged, it means the first argument is the data, the second argument would be the key column, and that key column is the one that will take the groups or factors that you want to gather, and in the argument following the key argument we have the values, and we're going to name the values in this case. We'll name them wind speeds. Okay, and now we have the dot. So in this fourth argument for gather, we'll name all of the columns that we want to gather into stations. So we can make a big list here of each one of these columns. There are 12 of them, but we can do what we did before, and we can just negate the one that we don't want to gather, and that's pretty simple. It works for us. So we'll just go ahead and do that, and now we can again take a look at Wind4 structure, and we can see what we have. So we've got data frame. Now we have 78,888 observations, and we've got 3 variables. We've got the date, we've got stations with their characters, and then we have the wind speeds, which are numeric. So that worked out. But we can also look a little bit more closely here, or in a different format. We can see something that we're more familiar with, and we can see that we've got the date, and then we've got the stations, and then we've got the wind speeds. Okay, so that's successful. This is tidy data, and we can see that we've taken the data where the year was in 2 digits. First, we loaded the data into R using read.table. We added headers, and then we cleaned up the data a little bit. We took the year and turned the year into from 2 digits into 4 digits, and we combined the year and the month and the day into one format as a date format, which we did with LuberDate. And then what we did was we went ahead and dropped some of the erroneous columns, and then we went and we gathered these columns. We tidied this data up by gathering the columns that were representing the same variable in multiple columns. We gathered those into one grouped station, and then and we have also the associated values, which we've renamed as wind speeds. We'd like to look at the bottom of this data set, and that will give us a chance to see that we do indeed have different stations. You can also see we're from 1961 to 1978. Okay, so that's not bad. And now that we've done that, we can take a quick look at some of this data. And one of the things that we can do is we can run some simple statistics on it. Let's do that. Okay, so this isn't very interesting data. We've got just the date and the stations and the wind speeds across a number of years. We actually don't have a lot of other predictors. If we wanted to do a regression that was useful, maybe we wanted to look at temperature, wind speeds, and we wanted to come up with probability of there being a forest fire given a certain type of terrain. We would need to have some data on the type of terrain. We might want to take some data on temperature. We might want to group our data into the type of year, what kind of year it was. We might want to look at precipitation. We might want to then have some data on forest fires, and then we could run sort of a prediction, or we could maybe do a prediction algorithm, or so on and so forth. There's a lot of interesting things that you can do when you have more data. In the case of a data set like this, we basically have only one piece of data that's of any interest, and what we're going to do is we're going to just take some averages. So we can see what the average wind speed is, and we can see what the average wind speed is across all the data, across all the years and all the stations. So we'll do that. And we will just call this average. And so to do this, we can use summarize, which also comes from the dplyr package. And summarize takes an input. In this case, just go ahead and do it. Second argument for summarize is the name of the new column, and that is typically we do a function. So in this case, we're going to do the function mean, and we're going to run mean of wind 4, and then we're actually going to run wind speeds. So I think that should give us just one variable, and it does. It gives us the mean, which is 10.22837 knots. So we can see that for all of this data, of which we had 78,888 observations, we can see from 1961 to 1978, across all these stations, the average wind speed is 10.22837 knots. Okay, so let's do another one. Let's look at average wind speed, and this time let's do across all years, but let's group by station. So to do this, we're going to introduce what's called the piping operator. And the piping operator is similar to the piping operator that you can have in PowerShell. In PowerShell, you have a piping operator. So in PowerShell, you have a piping operator, and R also has a piping operator, and I think it comes from the deploy-R package. The way it works is everything that's on the left-hand side of the piping operator goes into the input argument, the first argument for the function on the right-hand side. So what we're going to do is we will name this one average, and then we'll go station. Station will tell us that it's grouped by station. And then we're going to, we'll put our, so because we're using the piping operator, we put our input argument first. And in this case, the input argument will be 4. And then we do the piping operator. And then we can do our summarize. But before we do summarize, we want to be grouped by. That's right. And then we want to do group by station. And in this case, it's called stations. I don't think we have to put quotation marks, but we'll go ahead and we'll do the piping operator again. And this time we'll do summarize. So what we didn't do with group by is we didn't put a argument for the input, which is the data frame that we're working with, Win4. And we didn't do that because Win4 is on the left-hand side of this piping operator, and that means everything on the left-hand side of the piping operator, except for this assignment. This is assigning everything into average station. So everything on the left-hand side of the piping operator goes into the first argument of group by. So the first argument of group by happens to be the data argument, wind_4. And now we go from group by, we go to this piping operator, and everything on this piping operator is wind_4, grouped by stations, and that goes into the summarize function. So summarize doesn't have to have a data argument as its first argument either. We can just jump ahead and go right to the, which is a column, so we're going to give it a capital letter because we're naming it for a column, and then we're going to use the mean function, and in this case we can actually just put the name, as I understand, wind speeds, and we can just go ahead and send this over to the console. Okay, so now we can take a look at this average station, and let's try 10, 20 will be fine. We'll have a look at that, and we can see, now we see it's actually, now it's called a table, and it's only showing us these 12 columns. That's because we did the average grouped by station for all years. So that's fine. There are only 12 columns, and the table is not cutting us off. But why is it a table? It's turned it into a table at some point, and I think it did it when we did this group by, and it just kind of turned it into a table. A table is a table data frame. If we go ahead and look at the class here, we can see that. We can see that it's got 3 classes. It's got the table data frame, which is called the table, and then it's got the table, and then it's got the data frame. So the difference between a data frame and the table data frame is that the table data frame, if you just go ahead and if you have 500,000 observations, and you go ahead and you input that data frame without using something that shortens it, it will shorten it to the first 20 observations. So you don't have to worry about doing a mistype and then it uses up all your memory and shows you this massive data frame and you have to stop what you're doing. You can have that as a backup, and it's also shorter and more concise way of doing it. So Tibble is something that you can do. If you want to turn something into a Tibble, you can actually just use as underscore Tibble, and it'll take a data frame and it will turn it into a Tibble. We're not going to do that here. It's done that for us. So we've got the class of the average station, and you can see over here that what we did was we grouped by station, and then we took the summarize for the wind speeds of we took the mean for the wind speeds, and what we've gotten back is we have each station, and each station has a mean for the wind speed across all the years in our data set. So we can see that some stations have a much higher average wind speed, other stations have a much lower average wind speed, and this gives us the average wind speed across all the years. So that's successful. Okay, so let's do one more. Let's take a look at average wind speed grouped by year and by station, and we can do that. This is getting to be a long tutorial, but we'll just go ahead and do this one more, and then we'll call it a tutorial. So you can see average wind speed grouped by year and by station. So how do we do that? Actually, we do that in a very similar way. We can use the piping operator. We can name it year, and we can name it station. We can see that we're going to put wind 4 in, and now we have to do something a little bit different. We're going to group by station, and then we're going to make a new year column. You can do a new column, and we do group by, and what we don't have is we don't have years. We actually have dates now. So because we have dates and not years, we want to make a column called year, and we want to make that column again using Lubridate. So we'll just do that. We didn't load the library Lubridate, so we're just using the double colon operator. And Lubridate has a function called year. So what year does is it takes a date, and from like a date format, so a date format will have kind of a distinctive year in it, and this function year from Lubridate knows how to find that year. So it will take it will extract the year from the date value. So we have year, we have Lubridate, and what we're going to do is we're going to have a look at we're going to extract from the date. Okay, so if that should work, and we could probably not even put wind 4 in there, but let's not worry about that. Let's just go ahead and do this. So that's what we'll do. We'll just go right ahead and do this and see if that worked. And this should be a Tibble now because we did group by, so we don't have to worry. We can just have a look at it. You see Tibble shortens it. There's 206 more rows. Our data, so here we have a year column. That shows us the year. It's grouped by year, and then we have the mean column. So that was successful. So let's look at a few more stations. If you want to look at Tibble a little bit more, you pretty much unwrap it. And so you do okay, so 12 times 3 is 36. And let's try that. Okay, so what this did was it's showing us the first 36 observations, and that allows us to see that we've grouped by station. And So this is showing us the value for every year for each station. So the first station is Bell, the second station is Burr, and we can see that it's showing us 1961. It's got the mean wind speed at that station, and then it's got this mean wind speed at that station for 1962, and so on and so forth. And this is okay, but let's do it again. Let's change it. Let's put stations active here. Okay. So now when we look at it, we can see for each year we've got each station and we've got the average wind speed. So 1961, and we can see for 1962, we can see each station, and it's got the average wind speed, and we can see that for 1963 as well. So this is useful. You know, if we were doing maybe an interactive bar chart, interactive histograms that you could look at online, and you wanted to, you know, select a station with your cursor and then move that station across the years, and you could see the average wind speed change for the other stations as well. You know, this would be a way that we can group that data. We can also do some bar charts that are interesting, and so on and so forth. So there's some stuff that we can do with that, and you know, I think what we can do is we can actually we can split this, and I think we can do it like this. And then we can just look at this like this. And this way we've kind of sort of separated it into little data frames. So it's still a data frame, but it's formatted more as a list, and we can see each year sort of more separately. That's interesting. So 61, 62, 63. Okay, so what we've done in this tutorial is we downloaded some data, and we set the working directory. We downloaded some packages and installed some packages, and we loaded some libraries, and we found ourselves some data, and we saved those URLs. We downloaded that data. When you download the data, you want to get the download date. And we're going to do that. So that loads into our namespace, which we can see right here. You can see that we have now the download date, and that tells us when we downloaded the data, which is important because sometimes data will change, so you'll want to have downloaded that data. So we downloaded the data, we read the data into R using read.table, and we were able to get that data into R. Before we did that, we looked at the data and we examined it, and we saw that what kind of changes we want to make to it, and we set it up so that we could download the data into R, and then we had a look at that data. There's a number of different ways that we were able to look at the data. Then we cleaned up the data. We changed the year from 2 digits to 4 digits. We combined the year, month, day into a date column. We dropped erroneous values. We tidied the variables that were spread across multiple columns into one column. And then we ran some simple statistics on the data. We were able to look at the average wind speed across all years and all stations. We were able to look at the average wind speed across all years grouped by station. And we were able to look at the average wind speed grouped by year and grouped by station. And the way that we did that was we did that with the piping operator. And we also learned about the double colon operator, which is a way of, instead of loading the library, we can call functions from within the library for one instance. And then we also looked at how you can look inside of a tibble. We explained a little bit about what a tibble was, and then we used the split function to take a very large data frame and group it into distinct frames by using the split function. So the last thing that we want to do is we want to save.image. And save.image is how we would save our namespace so that we get all of the variables which have our URLs and our download date and our data frame, and we can get those variables into R. And we would save this data, and then we would load the data as well. So I think if we do this, we would just, let's say, call it tutorial. We could call it tutorial wind speed and .r. Okay, so we'll just save the image, and now let's have a look and see if it saved the image. Yep, so the image is saved, and we'll just say what it is. And then the next time you want to have a look at it, you would load your workspace. So load workspace, you do that with, I think it's load .image. It's either load.image or just load. Yeah, I think it's just load. So the question mark before function will allow you to look at the arguments in that function. So load will work. Okay, so that's a successful tutorial. Hopefully you learned something, and we'll do another tutorial another time. Thanks for watching.